All right, guys, welcome. We are going to go over this study guide for the entire Unit 12 test. You guys can take notes all over your study guide, do whatever you need to do, and you can use that on the test, okay? So we're going to write a lot of notes and stuff on here. Couple of things real quick. On number 15 and number 16, we're going to go ahead and just make those positives. Because when we did those, we talked about how it's a little trickier with a negative. Let's make this easier, okay? Down to 24, 25, and 26. We're crossing those out. We're not going to do half angles. We did not have time. All right, and then I believe, yeah, starting with 35 on, we're not doing any of those, okay? Now your test is going to look extremely similar to this review. So let's get started. All right. First of all, for every trig function, you guys can see these trig functions down here, okay? Sine, cosine, tan, cosecant, secant, cotangent, right? For all of them, well, actually, hold on. Let's say it like this. The amplitude is the absolute value of A. Now, this is for sine and cosine. For everything else, the amplitude is none. Because remember we talked about this, the little like liney things go off into infinity or whatever. For all the rest that are not sine and cosine. Those, the amplitude is none. Okay, for sine, cosine, cosecant, and secant, the period is 2 pi. I'll write this and be consistent here. 2 pi over b. And for tan and cotan, the period is pi over b. Okay, so we're going to start with one of each. So here we go. All right, for number 1, the amplitude is 3. The period is, this is a 1 right here, so it's 2 pi over 1, so it's just 2 pi. Okay, now what that means is I'm going to mark my y-axis with a 3 and a -3, okay? And I'm going to mark my x-axis with a 2 pi and a -2 pi. Now, if it's 2 pi right here, and we go out here to 2 pi and -2 pi, and then you guys remember that we divide this by 4? If you divide the period by 4 and I get pi over 2, and then that's how we label everything. 1 pi over 2, 2 pi over 2, which reduces, 3 pi over 2, 4 pi over 2, which reduces, okay? But if it's like 2 pi, this is like already set up for you. Okay, once you guys have all this, the amplitude and the period set there, what you're going to do is remember sine starts at 0 and goes to whatever A is. So this graph would start at 0 and go to 3. 0, -3, 0. We just draw that through. Okay, we just do the same thing on the other side. 0, 3, 0, -3, 0. Do the same thing. And we go like that. And that's it, okay? So make sure the things that I'm going to be grading, all right, a point for amplitude, a point for period, a point for having these labels across the bottom there, and then and labels there, right? And then a point for the graph, okay? Cool. All right, let's move on over into cosine. Okay, we have an amplitude here of 5, and the period is 2 pi over a half. Now, when I do that, 2 pi over a half, it's the same thing as 2 pi times 2. So this period is actually 4 pi. Okay? So we're going to go over here and we're going to go to 5, -5, right? And then over here, we're going to fix that and say 4 pi and -4 pi. And then we're going to divide that by 4. And so you think to yourself, what is 4 pi divided by 4? Because we need to cut it up to get all those parts. That's just pi. Okay? So we divide this by 4. I'll just make a little note over here. We divide it by 4. and then that's what we use over here. So it's 1 pi, 2 pi, 3 pi, 4 pi. Same thing on the other side. Okay, so I took care of my amplitude and period. And then what we're going to remember is cosine starts at A, goes to 0. So it starts at 5, goes to 0, negative 5, 0, 5. Okay? And then we just do the same thing on the other side. Negative 5, 0, 5. Okay, so we're going to graph 2 full periods of each graph. All right, perfect. Okay, I think I'm going to do these out of order. I am going to do tan and cotan last because they're similar to each other, but they're totally different than what we're doing here. So I'm just going to continue on. I'm going to do this one next. Okay, cosecant is the reciprocal of sine. So what you do is you draw this exactly as if you were drawing sine. Okay? So I would go like this. The amplitude is 1/2. The period is 2 pi over 1. So it's just 2 pi. Okay, so again, you guys, I'm going to go through here. And I'm just going to do what I was doing for sine. Okay. The period is 2 pi, so this is all labeled correctly. This is fine. The amplitude is 1/2. I'll go ahead and label that. And I'm going to make a sine graph. And when I make it, I'm going to make it like kind of dotted or in a different color or something like that. So remember, sine starts at 0, goes to A, and then goes to 0, negative A, 0. Because this is 1/2, this is like really a small graph. Okay? And then you remember that all through here there are asymptotes where this hits 0. You want to make sure that you do not cross, put that in the wrong place, any of these lines here. Alright? And what we do is we then go, we take this, we take the top part of that, okay, and just make like these parabola looking things off of the maxes and mins of where sine was. That should be more in the middle. There we go. Okay. That's our graph of cosecant. Okay, if I'm going to do secant, let me go ahead and say that that goes with cosine. Alright. Amplitude is 2. The period is 2 pi over 2/3. Alright, and so what I get for my period is 3 pi. Now look, that's going to go here and here. And remember, this is with sine, cosine, secant, cosecant. The way that you figure out all these parts leading up to it is you divide the period by 4, reduce it if you can. That does not reduce. So this is 3 pi over 4. Add that to itself again. That's going to be 6 pi over 4. Add that self to it again, 9 pi over 4. Add it again, 12 pi over 4. And then reduce it. So that's 3 pi over 2. That one does not reduce, so it's 9 pi over 4. And then 12 pi over 4 is 3 pi. Okay, so we get all the way through there. Perfect. We just copy it on the left. 3 pi over 4, negative 3 pi over 2, negative 9 pi over 4, and then negative 3 pi. Okay? And then I'm going to draw with a dotted line. Sorry, let's not do that. Okay, I'm going to draw with a dotted line cosine. Remember, cosine starts at A, goes to 0. Oops, that one a little too high. Okay, starts at 2, goes to 0, negative 2, 0, 2. And then, you know, you don't even necessarily have to draw the asymptotes as long as you're just paying attention to where that crosses the axis. That's where we need to be careful. And then I'm going to go back and I'm going to draw off the ends of each of these guys, okay? That guy keeps going over there, and that guy keeps going over there. So you can draw it, or you can like leave it like this. All right? That's all do secant. Now, tan and cotan are completely different, okay? For tangent, the thing I want you to remember, and you like kind of start drawing this different too, is you start at 0 with a point, like at 0, 0. And cotangent, you start with an asymptote. So my first thing I'm going to do right here, make it like kind of thicker, is an asymptote right there. And with tan, the first thing you're going to do is just a point right there. Okay? Now, I just realized I kind of messed this up. This, actually, the amplitude is 1/2, except for when we do secant, it's none. And then this amplitude was 2 when we drew the cosine. But when we did the cosecant on number 4 and the secant on number 5, I should have put none for that. Okay, so try to remember to put none on all these ones that like go up forever. That one doesn't really have an amplitude. Although I will tell you what that number is for the 1/4 and the 1/2. Okay. All right. Now these have a different period than what we've been using. It's pi over b. So the period is pi over 2. Okay. Now what that means is that from dot to dot, that's pi over 2. And then dot to dot, the next one, that's another pi over 2. That would make that pi. Okay, and every time I go from dot to dot, it's another negative pi. And then you got to figure out the ones in between. Like if this was pi over 2, this one's got to be pi over 4, right? Because that's half a period. It's halfway between the dots. So that's 1/4, 2/4, 3/4, 4/4. Okay, and I'll just do the same thing over here. All right, now everywhere there's not a dot, I'm going to put an asymptote through all of these guys. So every other point is either a dot or an asymptote. And then here's how we draw it, okay? This is where the 1/4 comes in. That tells me that from the 0 right here, I go a 1/4 down and a 1/4 up, and then I draw it. Okay? From the 0, I go a 1/4 that way, a 1/4 that way, and I draw it. Okay, a 1/4 that way, a 1/4 that way, and we draw that. Okay, that is my tangent graph. Now, if I come over here and do a cotangent graph, okay? So first of all, again, every other is going to be an asymptote, just like was on here, every other one. So there's an asymptote. There's an asymptote. Same thing on the other side. Now, it has a 1/2 in front. That's going to help me when I graph it, but the amplitude is none. The period, though, is going to be 2 pi over 1/3, which is 6 pi. Now, again, that's between every 0 or every asymptote. So between that asymptote and that asymptote is 6 pi. Between that one and that one is 6 pi. So that would be like 12 pi. That would be negative 6 pi. That would be negative 12 pi. And then if I cut that in half of 6 pi is 3 pi. So 3 pi, 6 pi, 9 pi. That's how this one's going to go. Now the other thing that you want to, and that's where all the zeros are, right? So every other spot is an asymptote or a 0. Okay? Now I want to draw these cotangent. You got to draw these down. With the 1/2 right there, I go a half here, a half here. These I draw down. So if you want to make a note for that, you would say cotangent goes down like that. And then if you want to make a note over here, tangent goes up like that. Okay? Okay, that goes like that. It goes goes like that. Alright, and this is just at a half and a half. Okay, and there goes my graphs. So that's the basics of the first, one of each with just an amplitude change and a period change. Okay, now we are going to move on in 1 second to the shifting them around. Okay, so this program I'm using to record my iPad, it makes me restart it every 10 minutes. So that's why there are a lot of breaks in this video. I'm very sorry. All right, now we're going to talk about how you do these when you're moving them around. We have a sine, a tan, and a cosine. Okay, so let's start with sine. So first thing, that is my amplitude, 3 over 2. 3 over 2 is like 1.5, so I'll put it right here and right here. Okay, I have a 2 right here, so my period means that's 2 pi over 2, which is pi. So what that means is that I write pi right here. Okay, I write negative pi right here. I remember to divide that by 4 to label the rest. So that's 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, which doesn't reduce, and pi. And I write those on this side too. Negative pi over 4, negative pi over 2, negative 3 pi over 4. Okay? Now, I am going to do, what I usually do is I do just this part with the amplitude and period, and I like dot it or something, draw in a different color or whatever. Sine starts at 0, goes to A. So it's going to go like that. You don't even necessarily have to do the whole thing. Then you do the phase shifts, all right? Now, this shift, it has right here plus 1. That's actually a vertical shift. It goes up 1. And when it goes up 1, it makes this midline, the middle line, up 1. Y equals 1 instead of y equals 0. And so what I do is I just move each of these points up 1. So that point that's at 3.5, sorry, 1.5, 1.5, goes up to 2.5. 0 goes up to 1. Negative 1.5 goes to negative 0.5. And then 1, and then I can draw that. Then I just got to copy it on the other side. So it went to negative 0.5. And then it went up to 1. And then it went up to 2.5. And then back to 1. Okay? And that's my graph that shifted. This one did not have a phase shift. All right, let's look at my next one. Tangent. Okay, tangent. We start with a dot. And then we have an asymptote. Here, dot, asymptote. Okay, I'm just going to draw a couple. All right. The amplitude, because it's a tangent graph, is going to be none. The period is pi over 1, so the period is pi, which means from here to here is pi, from every dot to every dot. Which means that this is halfway through that. That's at pi over 2. So actually the labeling it has is fine. Now, the only thing that this one is telling me, the midline doesn't change, so that's still at 0. It doesn't have a vertical shift. But it's telling me minus pi over 4. That means I need to go, minus means opposite, right pi over 4. This is opposite if it's inside the parentheses. So write pi over 4. Now, look at what this tells me. My labeling tells me 2 boxes were pi over 2. So 1 box is pi over 4. Okay? So I'm going to do this in a different color. I'm going to move that asymptote. Well, I guess we can do it like that. No, that looks weird. Okay, here, I meant to do this. Okay. So I'm going to move that asymptote over 1 box, and that 0 over 1 box. I'll move that asymptote over 1 box, the 0 over 1 box, the asymptote over 1 box, 0 over 1 box. Okay? Now, if it's too hard for you to see, you can erase some of the other graph that we had on there. But now you can see what this looks like. You just follow the pattern. A point, an asymptote, a point, an asymptote, okay? And that's good, so I shifted it over. And so now the only thing I need to do is actually draw it, and I draw it with the 1/2 right here, okay? That goes up a 1/2, down a 1/2, and then I draw. Up a 1/2, down a 1/2, and draw. And then up a 1/2, down a 1/2, draw. Up a 1/2, down a 1/2, draw. Okay? That's how you do your tangent graph. My labeling and stuff was okay on that, so I don't have to change it. Alright, and now I got one more. This one is like a little bit of everything. Okay. This one is, first of all, my amplitude is 2. Let's go ahead and mark that off. My period is 2 pi over a half, which is 2 pi times 2 over 1, which is 4 pi. So let's go ahead and put that in. That's going to be 4 pi. And if I divide it by 4, it's 1 pi, 2 pi, 3 pi, 4 pi. Okay. Let's see here. Well, actually, I'm going to stop right here. Just the amplitude and period, and I'm going to draw that dotted, okay? Now, cosine starts at 0 and goes like that. Okay, so this is cosine. All right. Now I'm going to start moving things around. Okay. The plus pi means it goes left pi. The minus 3 means it goes down 3. And then the midline is at -3. So left pi, now if I look, okay, how many squares is pi? That's 2 squares. And that's what my labeling is important for. So pi is 2 squares. So I'm going to go left 2 squares and down 3 squares. So let's see if I can do that. I'm going to start from over here. Left 2, down 3. I'm going to go here. Left 2, down 3. I'm going to go here, left 2, down 3. And then left 2, down 3. Left 2, down 3. So I can kind of see it now. I'm guessing that goes to there. Boom, 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 boom. So I'm going to go left 2, down 3. I was going to go left 2, down 3. Left 2, down 3. There we go. Okay, so it's just shifted to the left and down a little bit. All right? Okay, so hopefully that helps you guys with the graphing and that you made lots of notes for that. Now we're going to make sure we get out our side chick, right? I'll have our side chick here. We're not doing double angle or even odd, but the rest of it is fair game. And let's look at how we're going to do this on our review. Okay, now we're getting into some fun stuff. All right, when you guys get to where it says, okay, find the exact value of each function, and it gives you like some information right there, find the exact value. We're going to remember that these are triangle problems. You're going to go ahead and consult your best friend to look at where you would write these triangles, right? Now, my best friend is, where's my best friend? Oh, for goodness sakes. There he is. There's my best friend. On that side, we have labeled 0, pi over 2, pi, 3 pi over 2, 2 pi. So, like, if it says, okay, draw it between pi over 2 and pi, that means it's going to be in the second quadrant, right? So that's kind of the purpose of that. So between pi over 2 and pi, and that's for all of these, I guess. So we're just drawing all of these in the second quadrant, even though the sides and stuff are going to be different from each one. We're going to draw them all in the second quadrant at least. So these are all triangle questions. Okay? And you just have to know your like adjacent, hypotenuse, like that kind of stuff. So we can write this down too. You could write this on your best friend chart or whatever. Let me just write it below. sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. When I write the reciprocals, cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotan is adjacent over opposite. Okay? You can write those on your best friend chart if you want. Okay, so now we've got this. Okay, so sine is opposite hypotenuse. So that's 1, 3. Now on your calculator, you basically are going to do 3 squared minus 1 squared, which is 8, and then square root it. Now, 8 square rooted is 2 square root 2. So that's what I get on that side. All right, that's just doing a quick little Pythagorean theorem to figure out the sides of the triangle. Now, it wants me to find secant. Okay, secant is reciprocal of cosine. So that's hypotenuse over adjacent. So secant is 3 over 2 root 2. Now, there is one thing we got to remember. Did any of you catch my mistake? We're in the second quadrant, so that side needs to be negative. So it is 3 over negative 2 root 2. We'll just leave it like that. Okay? All right, here's another triangle. Cosecant is reciprocal of sine. Sine is opposite over hypotenuse. So this is hypotenuse over opposite. So it's 511. On my calculator, again, if I do 11 squared minus 5 squared, I get 121 minus 25, which is, I think, 96. Ugh, I really don't want to break this down. All right. Oh, this is going to be like a million twos. 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. Whew. 1 pair, 2 pairs. That crosses off. So 2 and 2, 4 will go on the outside with 6 left over, and it's negative. I don't think the ones on the test are quite this bad. I'll take a look and see, but you got to just, do all that. And then cotan is opposite of tan. Tan's opposite adjacent. This is adjacent opposite. So this is going to equal negative 4 root 6 over 5. Okay? All right. This is a little bit easier in my opinion. So this is opposite adjacent. That's 4 and 3. The negative goes with the 3. A little easier because it's a triple. We talked about our triples. 3, 4, 5. Okay? And so cosine is what? Adjacent over hypotenuse. And so cosine is negative 3 over 5. All right. And then my last one here. Okay, sine is opposite over hypotenuse. That is 3 over 7. So on my calculator, that's not a triple. So I got to do 7 squared minus 3 squared, which is 40. That's 2 times 20. That's 2 times 10. That's 2 times 5. So there's a pair of 2's. So a 2 comes out. The 2 and the 5 stay in. So that's 2 square root 10, but that is negative because it's going to the left. Okay? Once I got my triangle set up, I go, all right, tangent, which is opposite over adjacent. Tangent is 3 over negative 2 root 10. And we're just going to leave it like that. Okay? So those are called triangle questions. I don't know. I felt like the hardest part was simplifying the square roots. But that's only 1 point. Even if you forgot to do that, you'd still get most of the points on the problem. All right. Wonderful. Our next section we're going to do is sum and difference. So you're going to want to look for these at your side check. And we're going to do this. Okay. Where sine, plus is plus, minus is minus. That's the same. Cosine. Plus is minus, minus is plus, it's opposite. And tangent has a same and an opposite. Alright? Okay, now, when you guys see, let me look on the test if it's going to be labeled. I think it might be, but let's take a look. Okay, it's just going to say, like, find the exact value of and give you one of these. Alright, so you got to know that this is sum or difference. Okay, let's start with 345. If you remember on your unit circle, I remember we wrote it somewhere. Let's see if I can find it really quick. Did I write it on here? No, but we had all the circle going all the way around. I can't remember where we had it. All right, but you got to come up with two things that multiply to make 345. So what you guys want to do is find any two values on that unit circle that we made that was like 30, 45, 60, 120, 135, 150. I wish I could find it. I really might just have to write it down for you. I'll write it right here. Okay. It goes like this. First quadrant goes 30, 45, 60. That's obviously 0. That's 90. Okay. 120, 135, 150. That's 180. This is 210, 225, 240. That's 270. And then we have 300, 315, 330, and then that's 360. So you can use any of those to make up 345. So I think it's easy enough to use 345. Okay, so you got to split it up. Then you look at your formula sheet. This is my formula for tangent. So tangent of A, this was plus, because I did 300 plus 45. It's going to be tan A plus tan B, 1 minus tan A times tan B. Okay, so look at my formula. So this becomes tan A plus tan B, and then 1 minus tan A times tan B. Now you look on your best friend chart, 45, tangent 45, you just look here, is 1. So I'm going to use 1 for that. Now 330 is a little more difficult. If I take this, or 300 I guess, 300 is over here, okay? It's 60 degrees away from 360, so I'm going, what's the tangent of 60? And it's root 3. But also you got to pay attention to, it's ASTC. It's in the cosine quadrant, so it's negative, okay? So we go like this. This is going to be negative root 3 plus 1 over 1 minus negative root 3 times 1. Okay? And obviously you don't need the times 1 on the bottom. So negative 3 plus 1, 1 plus root 3. Now, there are other possibilities for answers if you split this up differently. For example, if you did like 315 and 30, okay, you're going to get a different answer, but it will be similar to that. It'll be shown to be the same as that. All right. 195, same thing. Let's look at numbers on our chart that are going to give us 195. Let's see here. 45 and 150 will work. 45 and 150. Okay? So I'm going to write this as 150, 45. And then I look at the sign. There it is. Sine, it goes sine, cosine, same, cosine, sine. Okay? So it's going to go sine, cosine, same, cosine, sine. Okay? Now the 45s are easy. Let's see here. Let's open this up. Okay, the 45s are pretty easy because sine and cosine are both root 2 over 2. Alright, so that's root 2 over 2. That's root 2 over 2. The 150s are a little more difficult. All right, we got to go like this. How far is 150 from 180? That's 30 degrees. So I have to do sine 30 and cosine 30. Now the only difference is this is in the second quadrant, which is the sine quadrant. So sine is positive. So that'll be positive, and cosine will be negative. And at 30, sine is a half. Cosine is root 3 over 2. Okay, when I put this together, I get square root of 2 over 4. And when I put that together, I get minus square root of 6 over 4. And I can put it all together and go root 2 minus root 6 over 4. Okay? All right, now, for the radians, here's how you do it. Okay, we go, I need two numbers. I'm going to put them both over 12. They need to add or subtract to make 1, because this is 1 by over 12. But they both have to reduce with 12, so I can't use like 6 and 5, because 5 doesn't reduce with 12. So let's see, how about 4 and 3? Now, that reduces to pi over 3, and that reduces to pi over 4. Now this is cosine and it's minus, okay? So it's cosine, cosine, opposite, sine, sine. And these are all right there in the first quadrant. So they're all going to be like right on your chart here. Okay? So cosine of pi over 3 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. We do the opposite with cosine cells plus. Sine of pi over 3. Oh shoot, I did this wrong. Cosine of pi over 3 is 1/2. Oops. Alright, we caught that mistake. Sine of pi over 3 is root 3 over 2. And sine of pi over 4 is root 2 over 2. So I end up getting square root 2 plus square root 6 all over 4. Okay? Okay, let's do this last one. Ugh, tangent. Tangents are such a pain. Alright, but that's fine. Here we go. Two things that add up to make 19, and they both reduce to 12. About 3 and 16. Okay, there's tons of stuff that you could use here. You could use 4 and 15. You could use 9 and 10. There's lots of things you could use, alright? I'm just going to use these. This is going to be pi over 4. And 16 and 12 is going to be, if I divide that by 4, 4 pi over 3. Okay. This is going to give me tangent, same, tangent, and then 1 minus tangent times tangent. Okay? Tan A plus tan B over 1 minus tan A times tan B. Looking at, oops, that's 4 pi over 3. Okay, looking at my chart. Pi over 4 is easy. Again, tan of pi over 4 is 1. So that's fine. The one that's a little more difficult is 4 pi over 3. Now 4 pi over 3 is in the third quadrant. It's 1 away from 3 pi over 3. And tangent in the third quadrant is positive. That's the T quadrant. And then tangent of pi over 3 is root 3. Okay, so it's going to be 1 and positive root 3. And then 1 minus root 3. Minus 1 times root 3. But there we go. All right. So, I think that's about half. So we're going to stop this video there, post this, and then our second video is going to cover the rest of these. All right? All right, here we go.